Okay, let's do some physics for fun. So there's going to be a roller coaster. There's one, down like that. And the height of the roller coaster is 50 meters. And what's rolling down it is going to be a big ball with a radius of 0.5 meters and a mass of 100 kilograms. And what we want to find is how fast the ball is going at the bottom of the roller coaster. Now, to solve this problem, we use energies, right? So initial energy is just going to be mgh because when we're just starting with gravitational energy and nothing else. And that's going to be 100 times 9.81 times 50. And that's going to give us 49050 joules. That's going to be our initial energy. Pretty simple. Now, for our final energy, things are going to get a lot complicated because when the ball is at the bottom of the hill, it's not just going to have kinetic energy, it's also going to have rotational energy. This is a big heavy ball that's rotating, and that rotation has inherent energy in it. So the formula for our final energy is going to be 1/2 mv squared, so that's just going to be our regular kinetic energy, plus 1/2 omega squared. Omega is going to be our rate of rotation. We use this letter. I don't know why. It kind of looks like a W. It's kind of annoying. Times 2 over 5 mr squared. And 2 over 5 mr squared is what we call the moment of inertia for a sphere. And this is something you just have to memorize. Starting off, we can plug in some numbers, right? So mass is just going to be 100. Here we go over here. And then r squared is going to be 0.25. Always good. But the problem is we still have two variables. So, how are we going to solve this? Turns out we can convert radians per second into meters per second. So converting radians per second into meters per second. And the way you can think about this is if we draw the ball up here, 0.5 meters, the radians around a circle is going to be 6.28 radians, right? That's just how we define angles. And what does that correlate to in meters? So of course, to find the circumference of a circle is just going to be radius times 6.28. In this case, it's going to be 3.14 meters. And we're converting radians into meters. So we want to know how many meters is in 1 radian. And now you can just do a cross multiplication. 1 times 3.14 divided by 6.28. Oh look, 0.5 meters is the same as 1 radian. So now we know this. We can take this omega and we can replace it with 0.5 v. And remember, it's squared, right? And when we square it, that squared also comes down to the 0.52. Anywho, this equation is starting to look very hairy, so we're just going to start evaluating it. Starting with the first term, this is going to be 1/2 of 100, which is going to be 50v squared, plus the second term, which is going to have a lot of constants. So it's going to be 1/2 times 0.5 squared times 2 over 5 times 100 times 0.25. It's going to come out to 1.25 v squared. And this final energy is going to be equal to our initial energy, 49050. And at this point, calculating this is pretty simple. 50v squared plus 1.25v squared is going to be 51.25v squared equals 49050. And just doing a bit of rearranging the square root, we're going to have 30.94 meters per second as the speed at the bottom. Now note that I did not include any sig digs just for simplicity, but remember that when you're doing an actual question in school, they'll probably bust your balls over sig digs. So just keep that in mind.